is simplifying algebraic fractions with unequal binomial expression denominators. So in the denominators we are having unequal algebraic expressions. So you have to find a common denominator LCM and thereafter we can solve the algebraic fractions. Let's have an example. So first of all, x plus 3 divided by x square minus 1 plus 1 time x square plus 2x plus 1. Okay, look at the denominators. These are unequal algebraic expressions. So we have to factorize them. Initially, we need to factorize them first of all. Thereafter only we can deal with our LCM. First, I will factorize the denominators. I'll keep the numerators itself as it is x plus 3. In the denominator, we are having x square minus 1. So here we can express this one as x square minus 1 as 1 square. So one factor with negative x minus 1 inside the bracket. Another factor would be x plus 1. We know the factorization of two square values and their difference. That's what I did here. Initially factorization. So 1 remains same. Look at the denominator. This is also similar like that one. This is a quadratic expression. So when you factorize this one, you will get x plus 1 into x plus 1. Okay. If not, I will factorize this one. X square plus 2x plus 1 means when I multiply both n members, it will become positive 1x square. So one and only possibility is to receive positive 1x square as a multiplication. It would be 1 times 1. Since it has positive, both should be positive to show the summation of that one should be 2x. Okay. So we got our factorization. So one factor would be x plus 1. Another factor also x plus 1. X plus 1 times x plus 1. That would be the factorization of this quadratic expression. Quadratic expression. Here also our work not done yet. I can write x plus 1 into x plus 1 as x plus 1 whole square. This fraction can be indicated as 1 divided by x plus 1 whole square. Now let's come to the LCM part. So in LCM, there are two different denominators. So I will select x minus 1. Both are only since at least if one of the denominator is having an expression, you need to incorporate that one into your LCM, x minus 1. These two are having same basis, but you need to select the highest powered one. Highest power would be square. So x plus 1 square. X plus 1 square. Our denominator task has completed. Okay. X minus 1 is the one and only expression related to minus x minus 1 expression, and x plus 1 it has two different values. We need to select the highest indexed one as a LCM. Thereafter, look at the denominators. Now x plus 1 square times x minus 1. Here x minus 1 into x plus 1 already there, so it should be multiplied with another x plus 1 to obtain the denominator x plus 1. And in the next one also, it is already having x plus 1 whole square as the denominator. So it should be multiplied with x minus 1. X minus 1, both numerator and denominator. Thereafter, let's multiply the expansion for this one. It will become x square plus 4x plus 3. And in second fraction, we will have 1 time x, it's x minus 1. Okay, x minus 1. Finally, the denominator remains same, x minus 1 into x plus 1 whole square. Let's do the operation between the numerators. X square remains same. 4x plus x, it will become 5x. 3 minus 1, it will become plus 2. So this would be our final answer. I'll repeat the question from the beginning again what we did initially. Since both are having different binomial, unequal binomial expression denominators, you need to factorize them separately. Before factorizing, don't do the LCM stuff. So after factorizing, you can directly write the LCM denominator. By looking at the denominator, you have to determine that what is the external factor you need to incorporate with the multiplication for respective both fractions. So since it is having x minus 1 into x plus 1, we need another x plus 1 quantity. That's why I multiplied the first fraction by x plus 1. Second fraction already having x plus 1 square, so it should be multiplied with x minus 1 factor. Thereafter, you need to do the expansion for numerator, final simplification. That will give you the answer as square plus 5x plus 2 divided by minus 1 times x plus 1 whole square as the solution for the algebraic fraction. So initially in the denominator, let's do the factorization. The first fraction that is already in the factorized form. So no need to worry about that one. Just keep it as it is, t minus 1 upon t plus 1. In the second fraction, you are having an unfactorized expression. T square minus, it can be expressed as 1 square. So the factorization would be t minus 1 times t plus 1. And now look at the denominators and let's determine what would be our common LCM for this. So to find LCM, t1, t plus 1, t plus 1. So I'll write that one as a representational denominator, and thereafter t minus 1 also should be included in our denominator. And then let's come to next part. So this is already having t minus 1, t plus 1. The first fraction only consists of t plus 1 in the denominator. So it should be multiplied with t minus 1 again with both numerator and denominator. So it will become t minus 1 square. Okay, t minus 1 times t minus 1. Look at the second fraction that is already having the LCM denominator itself. T plus 1 and t minus 1. Only the order changed, nothing else. So this fraction is not going to multiply with any expression. So we can keep the 1 as is. Then finally, you have to do the expansion for the binomial expansion. So it will become t square minus 2t plus 1 upon minus 1 divided by t plus 1 times t minus 1. Then the positive 1 and negative 1, positive 1 and negative 1, it will become 0. Okay, both after simplification it will become 0. Then we will have t square, we'll write that over here, t square minus 2t upon the denominator t plus 1 times t minus 1. Our work not done yet because look at the numerator. It can factorize furthermore as well. After completion of your simplification, sometimes you can simplify this expression furthermore as well. Yeah, it's possible because both are t multiples. So we can select t as a common factor. It will give you t minus 2. T times t minus 2 in the numerator factorization. In denominator, you will have t plus 1 times t minus 1. This would be the overall final answer. Initially, what we did, square factorization. After that, the identification of LCM and their respective subsequent process. Then expansion of this binomial expression. After that, simplification. After simplification, we are having a numerator. It is possible to simplify that furthermore. That's what we did, simplification like this to represent our overall final solution. So initially in this question, there is a quadratic expression. So we need to factorize that one. Let's do the factorization. A square minus a. So instead of that, I will write it as minus 1a minus 6. I will multiply both n members. It will give you negative 6a square. To obtain negative 6, there are some possibilities. 1 times 6, 2 times 3. Since the middle member is having a negative value, I'll give negative for higher values in each pair. Next one would be positive according to the multiplication. Then 6 and plus 1 it will become negative 5. So this is incorrect. This would be the suitable multiplication pair. Positive 2 and negative 3. So I can express this 1 upon a minus 3 remains same. After factorizing the quadratic expression, it will become a plus 2 times a minus 3. So simple. Now look at the denominators. Let's obtain the denominator from here. Both are having a minus 3 in same base. Okay, the powers are also same. And a plus 2 is also another expression. After this, look at the first fraction. It does not have any a plus 2 component. So I will multiply first fraction by a plus 2. So it will become a plus 2 times 1, a plus 2. Second fraction is already having the LCM as our common denominator. So no need to multiply that again. We can keep the 1 as it is. So finally it will become a plus 2 and plus 1 will become a plus 3 divided by, in the denominator we will have a minus 3 times a plus 2. A minus 3 times a plus 2. That's all for our simplification. Here the major task is to factorize. If you can simplify the do the factorization easily, the rest of the steps will be much easier to you. That's what I did here as well. A plus 2, a minus 3. Thereafter we determine what would be the LCM. By looking at the LCM, first fraction was multiplied and we got the equivalent fraction to obtain the final numerator. So in the question, factorization, I'll do the factorization directly. 3 upon, it would be a plus 3 times a plus 2. That is the factorization of the given quadratic expression. Plus 1 upon a plus 3 times a plus 1. That would be the factorization for second fraction. And thereafter, let's find the LCM. So the LCM would be a plus 1, a plus 2 and a plus 3. There are three different expression in both denominators. So all should be appeared in our common LCM. A plus 1, a plus 2, a plus 3. The first fraction is already having a plus 3 and a plus 2. So it should be multiplied with a plus 1 expression. Second fraction is already having a plus 3 and a plus 1, so it should multiply with a plus 2. So I will write the expansion for that one. 3 times a, 3a, plus 3 times 1, it should be 3, plus 1 times a, 1 times 2, 2. So then finally 3a plus a, it should be 4a, plus 3 plus 2, 5, upon a plus 1 into a plus 2 into a plus 3. That would be the solution for the given question.